The journey of mass-produced bread begins at the industrial scale, where massive metal silos store flour. These towering structures hold up to 50 tons of raw material waiting for the production cycle. Through the immense power of compressed air, this raw material is blasted into a colossal room. Inside the mixing chamber, electronic sensors ensure precise measurements of water, active yeast, and fine salt. Every gram is calculated by digital scales to maintain the strict consistency required for mass production. A giant industrial mixer then engages, using immense mechanical force to knead the dense, heavy dough. The machine works with rhythmic intensity, stretching proteins into a strong and highly elastic gluten web. This complex network of proteins is essential, as it will eventually trap the expanding gas bubbles. Without this structural integrity, the bread would fail to rise properly during the subsequent baking phase. This initial phase is a true feat of high-energy engineering, demanding precision and raw mechanical power. The process transforms simple, humble ingredients into a massive, uniform mountain of soft, pliable dough. By focusing on the scientific necessity of gluten development, the factory ensures a superior final texture. Precise ingredient ratios are maintained by automated systems that monitor the mixture throughout the entire cycle. The factory sets the stage for a perfectly consistent product, leaving nothing to chance or luck. Modern food production is as much about sophisticated chemical processes as it is about mechanical power. The sheer scale of the operation highlights the incredible efficiency of contemporary industrial-scale food automation systems. Every rotation of the massive mixing blades contributes to the uniformity of the final bread loaves. Sensors pulse with data, confirming that the hydration levels are perfectly balanced for the yeast activity. The air in the room is thick with the scent of flour and the hum of machinery. Engineers monitor the control panels, watching as the dough reaches its peak state of elastic development. It is a symphony of steel and chemistry, working in harmony to feed a hungry global population. The dough begins to pull away from the sides of the mixer, signaling the end phase. Each batch is identical to the last, ensuring that every consumer receives the exact same quality. This is the foundation upon which the entire industrial bread-making process is built and sustained daily. The massive mountain of dough waits to be moved to the next stage of the line. Gears grind with purpose, pushing the heavy mixture toward the waiting chutes of the assembly line. The engineering behind this process is designed to minimize waste while maximizing the total daily output. Automation allows for a continuous flow, preventing any bottlenecks in the high-speed production of the bread. The gluten structure is now fully formed, ready to withstand the rigors of the upcoming thermal processing. Every aspect of the mixing room is optimized for speed, precision, and the highest possible food safety. Giant stainless steel arms continue to churn, ensuring that every molecule of flour is fully hydrated. The temperature is strictly regulated to prevent the yeast from activating prematurely during the mixing stage. Cooling jackets around the mixer bowl absorb the friction heat generated by the high-speed mechanical kneading. This meticulous temperature control ensures the dough remains stable and ready for the next automated step. The sheer volume of dough produced in a single hour is enough to supply thousands of homes. Workers observe the process from behind safety glass, ensuring that every mechanical component functions without error. The mixture becomes increasingly smooth, losing its initial granular texture as the gluten network strengthens further. A soft, golden sheen develops on the surface of the dough, indicating the perfect level of hydration. The mixer slows its pace, gently folding the dough one last time to ensure absolute structural uniformity. Sensors detect the exact torque required to move the dough, confirming it has achieved desired elasticity. The massive mixing bowl tilts forward, preparing to discharge its heavy cargo into the waiting chute. A heavy, rhythmic thud echoes through the factory floor as the dough begins its descent downward. The transition from the mixer to the conveyor belt is seamless, designed to maintain continuous production speed. Every movement is choreographed by the central computer, which orchestrates the entire factory floor in real time. The dough lands on the belt with a soft, heavy impact, ready to be divided into smaller portions. This critical transition point marks the end of the mixing phase and the beginning of shaping. The factory floor remains spotless, as the automated systems handle the dough without any human contact. Efficiency is the primary goal, and every second saved in the mixing room increases the daily output. The dough is now a cohesive, living mass, teeming with the potential for a perfect rise later. The smell of fresh yeast fills the air, signaling that the biological process has officially begun. Engineers verify the final weight of the batch, ensuring it matches the production schedule for the day. The conveyor belt begins to move, carrying the dough toward the high-speed cutting and shaping machines. Each segment of the production line is synchronized to maintain a steady, unyielding flow of raw materials. The massive mixer is immediately cleaned by automated sprayers, preparing it for the next incoming batch. This rapid turnaround is essential for maintaining the high volume of production required by the facility. The dough moves steadily forward, leaving the mixing room behind as it enters the division zone. The precision of the industrial process is truly impressive, turning raw ingredients into consistent, high-quality food. Every loaf that will eventually reach the supermarket shelf starts here, in this massive mixing chamber. The industrial giants have done their work, transforming flour and water into the foundation of bread. Now, the dough continues its journey, moving toward the next stage of this fascinating, automated industrial process. Following the initial mixing, the dough enters a high-speed assembly line of division and thermal processing. An industrial divider uses powerful pistons to slice the massive dough into perfectly identical, measured portions. These individual segments are then rounded and flattened by heavy rollers before being placed into tins. The metal tins travel steadily through a humid proofer, a controlled environment designed for yeast activation. Inside the proofer, the yeast consumes sugars to create the essential airy structure of the loaf. The dough rises steadily, expanding within the confines of the tins to achieve a uniform shape. Next, the tins move into a 100-meter tunnel oven that bakes the bread to golden perfection. Radiant heat envelops the loaves, transforming the pale dough into a crusty, fragrant, and finished product. After exiting the oven, the loaves are transferred onto a spiraling cooling rack for temperature stabilization. Cool air circulates around the bread, ensuring the internal moisture settles before the final slicing stage. The loaves meet high-speed band blades that slice them with surgical precision in a continuous motion. Each slice is perfectly consistent, reflecting the immense mechanical power and precision of the industrial line. Automated arms then gather the sliced loaves, moving them swiftly toward the final stage of packaging. Plastic bags are pulled open by air jets, accepting the loaves with remarkable speed and efficiency. Heat sealers close the bags, locking in the freshness of the bread for its long journey. This seamless transition from raw dough to packaged product highlights the brilliance of modern industrial automation. Every step, from the initial mixing to the final laser-like slicing, ensures total product uniformity. Thousands of loaves emerge from the factory floor every hour, ready for rapid global distribution. The entire process is a testament to engineering, where science meets the scale of mass production. These loaves are now prepared to reach supermarket shelves across the world, feeding millions of people. The factory hums with the rhythm of machines, a symphony of gears and sensors working together. Each loaf represents the culmination of precise chemical reactions and sophisticated, high-speed mechanical engineering processes. The assembly line never rests, maintaining a constant flow of product through the vast facility. From the raw ingredients to the final shelf-ready package, the industrial process remains remarkably consistent. Quality control sensors scan every loaf, rejecting any that fail to meet the strict aesthetic standards. The efficiency of the system allows for massive output while minimizing waste and human intervention daily. Modern food production relies on this level of automation to satisfy the global demand for bread. The bread, once a labor-intensive craft, is now a triumph of industrial-scale engineering and technological precision. As the final crates are loaded, the factory prepares for the next shift of continuous production. The cycle of industrial baking continues, turning simple flour into a staple of the modern diet.